Hello there, Mr. Sutton here, bringing you the AB Calculus 4-1 Extra Practice number 3 solutions on extreme values of functions. For this problem, we're trying to find absolute mins and maxes for this polynomial over the interval -1 to 4. Now we know because we always have to test out endpoints, we're going to be testing out -1 and 4 no matter what. But let's see if there's any other critical values to test out on this. So to find those, we take the first derivative and set it equal to 0. So that'll be -3x squared plus 8x, and then that -7 is just a constant, so we don't worry about that when we take the derivative. So setting this equal to 0, I can factor out, let's see, a -x from both of these. So that'll leave me with positive 3x inside, and then -8. All of that still equals 0. So we get critical values then of 0, and let's see, plus 8 divided by 3, so 8/3. And those are both on the interval from -1 to 4, so we have to test them out as well. Let's see. Yep, they are both on that interval. Okay. So we'll start by testing out -1. Plugging that back in, we've got -1 cubed, which is -1, but we're negating that whole thing, so that's +1. And then this is going to be 4 times -1 squared, so plus 4, and then -7. So we've got, let's see, this is 5 minus 7, which is going to be -2. Next, we're testing out 0. That's the next one if we're just going in order. That one's a little bit easier. That zeroes out anything with an x, leaving us with just -7. And then there's the next one, 8/3. Well, we've been kind of procrastinating on this one, but it's time to face the music. So here we go. We've got this thing being cubed. Let's look at the denominator first. That's easier. That's going to be 27. But then the numerator, we've got 8 cubed. So 8 times 8 is 64. And 8 times 64, that's going to be, let's see here, I think that's 512, because that's going to be 2 to the 9th, and 2 to the 8th would be 256. So 512 over 27, and that whole thing is negative. Next, we have 4 times 8/3 squared. Well, 8/3 squared is going to be 64 over 9. And then we have 4 times that, so 4 times 64 is 256, and we're all over 9 here. And then we're subtracting 7 from all that. Okay, still a mess. We don't necessarily have to simplify, but it's hard to tell how this compares to anything else unless we actually do combine all of this into one big number. So I'm going to get a common denominator. This -512 over 27, I'm going to leave that the way it is. But 256 over 9, I'm going to multiply that by 3/3. So 3 times 256, well, let's see here. That would be 600 plus 150 plus 18, just kind of splitting it up by the number places there. So 600 plus 150, that's 750, plus 18, that's 768 27ths. And then this last one here, multiplying 7 by 27. So that's going to be 7 times 20 is 140, plus a 49 is 189. All right. So combining all this stuff, we have -512 and 768. That's going to be, let's see here, 256. Subtract 189 from that, and that ends up being 67 over 27. So that was kind of annoying, but it's positive. That's the important thing here. So that makes it the absolute max so far. But now let's check out if we plug in +4. So if we do that, we've got -64 plus 64 minus 7. So that one's a little nicer. That just comes out to -7. So taking a look at all of these, -7 is the absolute min, and that happens in 2 spots. Absolute max is going to be this only positive value that we worked so hard with our fraction math to get, and that is going to be it for this one, absolute max. For this one, we're trying to find absolute mins and maxes for this weird cubic function. So we have an endpoint or two here that we have to test out no matter what. Let's see if there's any other critical values in between 0 and 3 though. So for that, let's take the derivative. That's going to be negative 1/3 times x minus 6 to the negative 2/3. And there is a kind of a mini chain rule going on in here, but the inner derivative is just 1, so we don't have to really worry about that. So let's turn this into something I can understand by looking at it. Just putting this in fractional radical form. This is going to be negative 1 over, and now we're going to have a 3 times, let's see, this is going to be the cube root of x minus 6 squared. So a little bit of a mess there, but it's a little bit easier to figure out what equals what now if I set this equal to 0. Now I'm trying to find places where this derivative is 0 or undefined. But since we have something that's a constant in the numerator, there's no way to make this fraction 0. This fraction will never equal 0. Okay, is it undefined anywhere? Well, this is going to be undefined. It looks like, let's see here, if I plug in 6 for x, but that's not in the critical values that I'm worried about, so I'm not going to worry about that spot where we're not defined. Okay, so now that means I just have to test out 0 and 3. So that means that if I plug in 0, I'm going to end up with, this is going to be negative cube root of negative 6. And if I plug in, well, let's see here. If I plug in 3, now I've got 3 minus 6, which is negative 3, so negative cube root of negative 3. And this is kind of a mess to look at in terms of comparing them, because we've got cube roots, we've got negatives going on. But I can actually split this up into cube root of negative 1 times cube root of 6. And then the cube root of negative 1 is also negative 1. So at the end of the day, this just becomes a positive cube root of 6. And I can do the same thing down here. This becomes a positive cube root of 3. And, well, if you're taking the cube root of a smaller number, you're going to get a smaller result if these are both positive. So cube root of 3 is our absolute min. Cube root of 6 is the absolute max. For this problem, I'm trying to find absolute max and min for this rational function. So I've got endpoints, 3 and 5, that I have to test in my candidates test. But let me see if there's any other critical values. So let's take the derivative of this thing to find those. I'm going to have to use the quotient rule here. U prime v minus uv prime over v squared. Let me get the box and ribbon set up to help me with that. So I have my numerator x. Denominator was x minus 2. Derivatives are going to be 1 and 1, so that's not so bad. Multiplying this out with the ribbon, we've got 1 times x minus 2, so just x minus 2 then. And then going the other way, we have minus x. All of that over x minus 2 squared. Let's simplify this a bit. These x's cancel, so this is just negative 2 over x minus 2 squared. And in terms of critical values, things that make this fraction either 0 or undefined, well, we have a constant in the numerator, so this is never going to be able to equal 0. However, we do have an undefined spot at x equals 2. Zeroes out the denominator. But 2 is not on the interval from 3 to 5. So we don't have any critical values on the interval, and we only have to test out the endpoints themselves. All right, well, testing out f of 3, that's going to be 3 over 3 minus 2, 3 over 1, which is just going to be 3. And then testing out 5, that's 5 over 5 minus 2, so 5/3. Between the two of these, it looks like 5/3 is smaller, so that's going to be our absolute min. And that makes 3, the only other one, the absolute max. For this problem, we're trying to find the absolute min and max for this function. So to make our lives a little bit easier, let's rewrite this as a polynomial. So we've got 2/3 x, dividing both of these things by 3. We have 2/3 x plus 5/3. And now for this one, we want to find if there's any critical values on our interval from 0 to 5. I mean, we're going to test 0 and 5 because they're the endpoints, but you might have some critical values. So our derivative, that's going to be f prime of x equals just 2/3. And there is no way for this to be undefined or 0. So that means there are no critical values, which means we're just testing the two endpoints, 0 and 5. Testing 0, we have, let's see, 2 times 0, this is just 5/3 then. Testing 5, we've got, let's see here, 10 plus 5 is 15, over 3 is going to be 5. So between the two of these things, we've got the absolute min is going to be this 5/3, it's about 1 2/3, and that means 5 is our absolute max. On this problem, I'm trying to find the absolute min and max for this polynomial. So for sure, I'm going to have to test out the endpoints in the function, but I also have to test out any critical values this function has that might be on this interval. To find those critical values, we'll set the derivative equal to 0. So let's take the derivative. That's going to be 3x squared minus 6x plus 3. That 2 just goes away because it's a constant. Setting this equal to 0 and solving, I'm going to factor a 3 out of all this. So that's x squared minus 2x plus 1. And then I can factor this a little bit more. So things that multiply to 1 and add up to -2, that's -1 and -1. So we have 3 parentheses x minus 1 squared, all equaling 0, which means that x must equal 1 to make this equation true. 1 is inside our range of values that we're testing. It's in the interval. So we have to test this along with -2 and 2. Okay, let's go ahead and test all those. So trying the original function on all these, f of -2 now, that's going to be -2 cubed, which is -8. This is going to be -3 times 4, so -12. This is -6, -2. So this is -20, -26, -28. Now let's test out x equals 1. So that's going to be 1 minus 3, which is -2, plus 3 is +1, minus 2 is going to be back to -1. And then finally, testing out +2, that's going to be 8 minus 12 plus 6 minus 2. So that's -4 plus 6 is 2, minus 2 is 0. Out of all of these, the most negative, the smallest, is this -28, so that's our absolute min. And there isn't really a whole lot of great choices for absolute max, but 0 is the least negative out of all of these. In fact, it's not negative. It's the only non-negative number, so 0 is the absolute max.